Welcome back, friends. Today is April 2nd, 2020, and this is your math video for today. Today, we are going to be exploring equivalent fractions. We've already done this throughout the year, but this is more of review and practice and just deepening our understanding of equivalent fractions. And so we're going to start by looking at our learning intentions. I'm trying something new. Obviously, if you can see, it's kind of weird. This like weird cloud background. Let's see how it goes today. So let me share my screen. And we're gonna start with our learning intentions as we always do. Remember, say them after me or repeat after me at home. Learning intention. Today we are going to continue our exploration with the Egg-Cartan fraction model in order to find fractions that are equivalent. Success criteria, I can explain why two fractions are equivalent to one another when the numerators and denominators are alike, they're not the same. Language intention, I use words from our fractions anchor chart, and our social intention, I do the work even when no one is looking. So we're gonna always begin our lesson with our lessons with our learning intentions and then our vocabulary anchor chart. Remember, if I say the word, you say the word, and you can do the gesture with me. So numerator, denominator, benchmark fraction 1/2, part, whole, partition, equal parts, equivalent, greater than, less than, equal to, a bar model, a pi model, number line, unit fraction, fractions that are greater than a whole. And we've talked about our models and our strategies that we've used or we've practiced, we tried this year. We have our pi model, bar model, our number line, our claims, which we're gonna go into one claim specifically today. And I didn't have space to add it, but we started to look at fractions of a set. When we're looking at not just a whole and figuring out what the fraction is of a whole, how a whole has been divided, but also looking at fractions of a set. So for instance, if I have 4 M&Ms and I ask like what fraction of your M&Ms are red, right? Like that's counting how many out of the 4 are red. Let's say 2/4 of them are red, 2 out of the 4. So we're gonna continue by looking at our do now for today, which goes back to one of our claims that we've done together in class. Claim number 1 states, if the numerators are the same, look at the denominators. The smaller the denominator, the larger the piece. Which symbol would make this comparison true? If we're remembering our claim, I'm gonna ask you to take out your math notebook and I want you to write down everything you see on this page, starting with do now up at the top, write down that claim. You're writing down which symbol would make this comparison true. 1/8, 1/2, right? And I just noticed that I forgot to write the symbol, so let me do that really quickly. Which symbol would make this comparison true? Greater than, less than, or equal to. And so the two fractions we're comparing are 1/8 and 1/2, and you're gonna give yourself some space. Of course, it's not the same on my computer screen. It doesn't give me as much space as maybe you can in your notebook, but we're going to compare it using the claim, but then we're gonna use 3 different models to make sure that we're correct with the claim and that the claim does make sense. So pause me now so that you can write it down in your notebook. All right, so you're back. Okay, that means that you're ready to do this work and that you at least have thought about which symbol would make this comparison true, greater than, less than, or equal to. If that claim says, if the numerators are the same, so let's look at both of these fractions. If I look at the numerators, I see a 1 in the numerator and then I see a 1 over here. Okay, so they're the same. Now I'm gonna look to the denominator. Okay, for this one, I have an 8 as a denominator and a 2 as the denominator. The smaller the denominator, the larger the piece. So if this is the smaller denominator, that means my piece that I get would be greater, or would be larger. Okay, so using my claim, for now, I'm gonna back it up by drawing my different models, but for now, I'm gonna use my claim, and I'm gonna say that 1/8, sorry, I meant to erase that. That 1/8 is less than 1/2, okay? But now we're gonna back it up with some models. So let's start using the bar model first. I'm gonna draw out a side-by-side bar model so that we can clearly see it. That's gonna be the one I'm gonna use to represent 1/8. And then I'm gonna use another color. Let's do maybe pink to represent another one. And I'm gonna try to do it right below. And make it the same size. And we make sure it's the same size because if we're comparing fractions, we need to compare same sized objects, right? Or same sized models in order to compare correctly. So now I need to grab a different pen and I'm gonna let's start with 1/2. I'm gonna represent 1/2 with this top rectangle, and then I'll represent the bottom rectangle will be 1/8. So again, this is kind of hard to do on the computer, so please be patient as I try to draw straight lines. But if I know the top model is 1/2, I'm gonna make a story in my mind. I'm gonna imagine this is like a chocolate bar that doesn't have any lines. It's just a big chocolate bar. And if I were to cut it in half with a knife, I'd probably cut it right down the middle, okay? That looks pretty equal. It's kind of hard to do it on the computer, friends, but I'm gonna shade it in so I can show you what 1/2 looks like. So that's 1/2, okay. So now I'm gonna look at the second fraction or the second bar model because I'm comparing side by side. I know that I'm gonna have to cut it into 8 total pieces. That's how my whole has been partitioned because I'm looking at the denominator. I have to partition that chocolate bar or that rectangle into 8 pieces. So I'm gonna try that now. And let's see how that goes. Let's use a blue. Well, I know I have to partition into 8 pieces. 8 is an even number, so I can start by splitting that in half. So I'm gonna try to split that in half. Let me do that again. That was awful. It's so hard to do this nice and straight. That's pretty good. Okay, so now I've split them in half, but now, well, 8, half of 8 is 4. So on each side, I'm gonna have 4 pieces. So I'm gonna try that again. And then I'm gonna go back in. Let's try that line again. That's a really bad line. Okay. It's not bad. It's okay. The parts don't look perfect, but we're trying our best here. So let me shade in. Now, how many parts am I gonna shade if it's 1/8? If you said 1 out of the 8, you're correct. So I'm gonna grab another color and I'm gonna shade in 1. So if I said I ate 1/2 of a chocolate bar while my friend ate 1/8 of a chocolate bar, it is obvious that 1/8 is less than 1/2 just by using this bar model. I can see it. That 1/2 is way greater than 1/8. So that claim is correct, but now I'm gonna use a different model this time. I'm gonna use my number line model. So I'm gonna do 2 number lines, one on top of another so that we can kind of clearly see it. Let me try that one again. Okay, and here we go. So I'm gonna start by writing out 0. I know that I'm partitioning a whole. So I'm gonna start by writing 0 and 1. So this is gonna be 0. And this is gonna be 1, and the same down here. This would be 0, and this would be 1. Remember that you're doing this with me. You're doing it along with me so that you have different representations, different models to compare 1/8 and 1/2, okay? So let's see. Let's start by using, let's do a half first. Half is going to be easier for me to represent on the number line. That just means I'm going to cut it down the middle, and this is going to be the same as 1/2, okay? Now, I'm going to have to do the same down here, but I'm going to have to partition this into 8s. I'm going to start by splitting it down the middle because 8 is an even number. And like I did earlier, right, I'm going to have to do 4 parts on this side and 4 parts on this side. So let me start by doing that. Now I have 4 parts, and I'm just going to go in. And now I'm just gonna make sure I have that represented well. So how many parts I have? I'm gonna do jumps with me. 1, 2, 3, 4, 5, 6, 7, 8 parts. Perfect. So I'm gonna draw a little star to represent where 1/2 is located on here, and then 1/8, one piece out of the 8 would be located here. So I'm going to do another story with this. If I said that I ran 1/2 of a mile and my friend ran 1/8 of a mile, who ran more? If you said I did, you're right? 1/2, it seems like it's longer on the number line, or it seems like it's greater than 1/8. So 1/8 is still less than 1/2. Let's do the pie model. The pie model is always kind of difficult because kind of hard to partition a circle really well, but let's try it. Why not? So let me do 2 circles. Let me pick a different color this time. Let's do red. And then another one. I'm trying to make it about the same size. It's kind of hard, friends, but let's try it. Let me see if I can do lines as well. Yep. Okay, so let's start with 1/2 because again, that's kind of easier to do. If I partition it right down the middle, that's what it looks like. I'm gonna grab another color and shade in 1 part out of the 2. And let's shade that in with me. This might be harder for you guys to do perfect straight lines at home, but just try it. And then I'm gonna grab another color. Let's do brown, and I'm gonna partition. Let's do a line. Let's do lines right now. Okay, so I'm gonna start by partitioning down the middle, try to make it as equal as possible. And then this one like that. I have forts now, and I'm thinking of a pizza. I used to work at, fun fact, when I was 15 or 16, that was one of my first jobs. I worked at Pizza Hut in Miami, in my neighborhood where I grew up. And I was a very good pizza cutter. I knew how to use the blade really well, and I would have to cut the pizzas, the medium pizzas, into 8s. And they loved it because all of my parts were equal. So now I've cut this pie model, this pizza, into 8s, and I'm gonna shade it in. I'm just gonna shade it in with orange this time, and just gonna shade in 1/8. The parts are almost all equal. It's not perfect, but that's okay. And again, what do we see? We see that 1/2. If I were to tell you, hey, would you rather eat 1/2 of the pizza or 1/8 of the pizza? Most of you would say, if you're hungry, right? Most of you would be like, oh yeah, I'd rather eat 1/2 of a pizza than 1/8 because 1/8 is much smaller out of the whole. So this is just a good review to do and look at all the representations and models that we utilized to really make a decision or to really understand which fraction is greater, right? So when we're comparing fractions, not only do I want you to use the claim, but I also want you to use another model to support your answer. So if you need to still write something down from the screen, go ahead and do that. I'm about to clear it, so pause me if you need to pause me. And here we go, I'm gonna clear all drawings. So we're gonna go to the next, our next activity, which is a number talk, and it still has to do with fractions. I want you to take a look. Number 1 is, what do you notice? And number 2 is, how do I solve this? So I want you to look at this number line. It says label each of the marks on this number line. And number 1 is, what do you notice? And number 2, how would you go about solving? So pause me to think, what do you notice? You're gonna write it down. I notice, anything you notice about this number line. And number 2, how would I solve this? I think I would solve this by, so pause me so that you can write that down and write this number line in your math notebook as well with the star, the 0, and the 1. Okay, and you're back. You might have said something like, well, Miss Maldonado, I noticed there's a star on the number line. I noticed that on the number line, it's from 0 to 1. You might have also noticed that there are 4 parts. And let's see if that's right. 1, 2, 3, 4. So it seems like this number line has been partitioned into 4 parts. Those are some of the things you might have noticed. You might have thought to yourself, well, how do I solve this? I have to label this, right? Well, I think I would solve this by maybe counting the number of parts on the number line or how it's been partitioned to figure out the denominator. That's how we figure out what the denominator is, how the whole has been partitioned. So I'm gonna grab a pen and I'm gonna grab a color. Let's do blue this time. So I'm gonna, to figure out my denominator, I'm gonna make some jumps. That was 1 jump, 2 jumps, 3 jumps, 4 jumps. So that so far right now, I figured out my denominator must be 4 because my whole has been partitioned into 4 parts. But now I have to label each of the marks on this number line. So if this is out of 4, the first, from 0 to 1, this is gonna be our first part. So imagine this is a big chocolate bar, right? This is 1/4 of the chocolate bar. If I keep going, well, it seems like this would be, if that was 1/4, this has to be 2/4. This was 2/4, this has to be 3/4. And then 1 or 4/4. Here's a little bonus that I'm gonna ask you to do. And let me just erase something here so I have some space to write. But I'm gonna ask you to look at that 2/4. What other equivalent fraction could we write? If I said I ate 2/4 of this chocolate bar, or I ate, go for it. If you said 2/4 is the same as 1/2, you're absolutely correct, right? So we could say that this 2/4 is the same as 1/2, and you're right. This is, if we cut it down the middle, that's a half. And how do I know that those 2 fractions are equivalent? 2 is half of 4, and 1 is half of 2. Give yourself a little pat on the shoulder if you're like, oh, this is easy peasy, Miss Maldonado. This is just good review for me. So if you need to pause it one more time to write it down, go ahead and do that. And I'm gonna erase it, and I'm gonna write down a statement that I want you to write down in your notebook in order to label a blank number line that's missing the fractions. We're gonna write a statement on how to do that. So let me clear all drawings, and let me get my text box going. So if asked to label a blank number line with tick marks, these are tick marks. These little lines that you see are tick marks. If asked to label a blank number line with tick marks, and the number line is between 0 and 1, I must count the number of jumps between 0 and 1 in order to determine the denominator. Okay, that's what we did. Jumped in order to figure out that the whole has been partitioned into 4 parts in order to determine the denominator. I then need to label each tick mark in order. If it's the first jump, it will be 1 out of, right? Depending on what your denominator is. Depending on the denominator you've determined or you found earlier. Okay, let me just read that one more time, and you're writing it down in your math notebook. If asked to label a blank number line with tick marks and the number line is between 0 and 1, I must count the number of jumps between 0 and 1 in order to determine the denominator, or how the whole has been partitioned. I then need to label each tick mark in order. If it's the first jump, it will be 1 out of, depending on the denominator you found earlier. If you keep going, right, that's going to be your second jump out of whatever your denominator is. You're going to have an exit ticket today, and I make sure you write this statement down in order to help you figure out what the exit ticket is, because you're going to have to label each of the tick marks on the number line. So pause me now if you need to. All right. I'm gonna clear my drawing again, so clear all drawings, and then we're gonna move on to our problems, I believe. Our problems and, it's not letting me go, here we go. Our problems and investigation for today, which goes back to finding fractions that are equivalent to one another. Okay, so problems and investigation. Ms. Delgado says she ate 9/12 of her egg carton this week, and Mrs. Alonso says she ate 3/4 of her egg carton. Ms. Delgado states that she's eaten more eggs than Mrs. Alonso because 9 eggs out of 12 is more. Do you agree or do you disagree with Ms. Delgado? And so there's a statement down below that I want you to write. I agree or disagree with Ms. Delgado because, so I do want you to write the statement that is highlighted in blue. And of course, I'm gonna ask you to figure out, what does 3/4 look like with this egg carton and represent 9/12. So I'm gonna just grab a quick little marker to tell you what I want you to write. So on this one, you're gonna represent 9/12. She's saying she ate 9 eggs out of the 12. And then Mrs. Alonso says she ate 3/4 of her egg carton. What is that gonna look like? Try it. It might be a little difficult, but I want you to try it. So pause me so that you can go do that. And that means that we're back. Okay, so for Ms. Delgado, that might be easier to do because we know, looking at the egg carton, that it already has 12 eggs, right? So she's eaten 9 eggs out of the 12. So I'm gonna grab another color. Let's get the highlighter in here. So this is gonna be easy for us to do. She ate 9 eggs out of the 12. So that's 4, 5, oof, that's not nice, but it's okay, 6, 7, 8, 9, which means that there's only 3 eggs left in her carton. Okay, so now let's do 3/4. That might be a little bit harder, but I'm gonna look at my denominator, and it seems like the whole has been partitioned into 4 parts. So, this whole has been partitioned into 4 parts. How am I going to do this into 4 parts? Well, I might just divide my egg carton in half first. Let me try that again because that is awful. Okay, let me get a line. Let me see if I can get a line in here. So it's been divided into 4 parts. I'm going to split it in half first. And then I'm going to split it down the middle. And now I'm looking and seeing if my carton has been partitioned into 4 big parts or sections, and it has, right? This is 1 section, 2 sections, 3 sections, 4 sections. And now let's shade it in. So I have to shade in, I've divided this into 4 parts, and I have to shade in 3 parts, not 3 eggs, but 3 parts out of the 4 parts. And let's see how many eggs that comes up to. So I'm gonna grab another color. So this would be 1 part, would be 1/4 of my egg carton. This would be 2/4 of my egg carton. And this would be 3 parts out of my egg carton. Whoa, what are you guys noticing? Is there something you're noticing right now? Hey, if you notice, you're like, wait a minute, it seems like 3/4 is the same as 9/12. You're right. So your statement might have said, like, I disagree with Ms. Delgado because actually 3/4 is equivalent to 9/12. When I draw out the egg carton model, I see that for both models, both teachers ate 9 eggs out of the 12 because only 3 eggs are left. And I'm gonna write these fractions side by side to just double check and see what the relation, because both fractions, I'm looking, let's write it down. But if I look at the numerators, they're not the same. If I look at the denominators, they're not the same. But I want to look and see, what is the relationship here? What is the relationship here? I wonder. I'm looking. Well, it seems it's as if, like, from 3 to 9 and then 4 to 12, it seems like it's been tripled. So it seems like somebody multiplied 3 times 3 to get 9, and then they multiplied the denominator 4 by 3 to get 12. Do you guys see that? You see the relationship between the numerators and the denominators. They're not the same, but there's a relationship there between the numerators and the denominators. Give me a check mark or give me a thumbs up if that's like starting to make sense. We're going to be looking at more of this in the coming videos and just getting like a hang of it, because it can be a little bit difficult. We're looking at these fractions that are equivalent to one another when the numerators and the denominators are different. So you can write me a comment on the YouTube video down below if you're like, oh, I'm still not understanding, this is a little confusing, just so I have an idea, so I know what we need to continue doing, okay? So I'm gonna pause it if you need to write it down, and if not, I'm about to clear it. So the last thing I'm gonna ask you to do is an exit ticket, and I am gonna ask you to write it down in your math notebook, everything you see. Ask your parents to take a picture of it, send it to my phone number, or yeah, I think that would be easier to do. This would be really hard to do on the computer. So exit ticket, label each mark on the number line and then write a statement stating which fraction is indicated with the star. So it's very similar to the number talk we did today. You're gonna write the fraction located where the star was placed is because I can't wait to see your exit tickets. I hope you're having a fantastic Thursday and it's not too stressful, and we miss you guys. See you guys in the next video. And I hope you like this crazy background.